So we are talking 9.2 part one. All right, so part one, we're getting into how to do a confidence interval for a population proportion. Okay. Remember in chapter 8, we had the study guide, right, with the two boxes. One was about means and one was about proportion. Same thing with confidence intervals. We're going to have one for means and one for proportions. So we're going to focus on proportions today. Okay, just proportions. All right. So first off, kind of like going into what is a confidence interval. So just remember back into chapter 8, we talked about a sampling distribution of our p hats. Okay, so imagine that sampling distribution with a bunch of p hats. It will be centered at the true population proportion p with a standard deviation of square root of pq over n. Okay, so that's stuff from chapter 8. Now, the thing with confidence intervals is, and that this is the big difference between chapter 8 and chapter 9, is that we no longer know what the population proportion is. It will not be given to us. All right. We don't know what the population proportion is. So we don't know what P is anymore. But we have a point estimate, right? From the last lesson, we have a point estimate of that P, which is P hat, the sample proportion. So when we use the sample proportion in the standard deviation formula, we get this square root of P hat Q hat over N. And what we call this is the standard error. The standard error. And the reason why we call it the standard error, it's not that we made a mistake, it's just that there's some margin of error that could be there, since P hat isn't always equal to P itself. All right, so when we talk about standard error, this is what we're talking about. All right, so let's go way back to the empirical rule real quick. Okay, the empirical rule with the sampling distribution of all these p hats, which I drew so beautifully up here on the top right hand corner, it's a bunch of p hats, right? Combine that with the empirical rule, we know that if we step out one standard error away from that center, we know that 68% of all these p hats will be within one up and down from that middle. Okay, so let me kind of like highlight that so you guys can imagine what I am imagining. So 68%, like right around this middle area. Okay, so let's say that is one standard error above and below. That shaded area will be captured, 68% of all the p hats will be in that shaded region. All right, now if we keep going, we'll go two standard errors, right? Let's say we go two standard errors out. Now, 95% of all of these guys will be within two standard errors. So it'll be something like, this pink area. All right, so 95% will be within two standard errors from that true P right in the middle. And then 99.7% will be within three. All right, so almost the entire curve, all the p hats will be within three. All right, so hopefully that is like old news, right? That's like empirical rule. We get that, 68, 95, 99.7%. But this is where it gets a little tricky. Let's say we look at it from p hat's point of view. All right, from p hat's point of view. So let's focus on the 95%, right? So this pink area here. 95% of the p hats are in that pink area, right? Based off that normal curve empirical rule, 95% of the p hats are in that area. So if I were to pick a random p hat out, if I were to pick a random p hat, there's a 95% chance that I would pick one in that pink area, right? There's a 95% chance I will pick a random p hat that is in that pink area. And that pink area is significant because all those p hats are within 2 standard errors from that middle p. Okay? So that means if I were to randomly pick a p hat, 95% chance it will be in that pink area. And if it's in that pink area, that means if I were to reach out 2 standard errors, right, I would catch that P. All right. There's a 95% chance that my P hat is no more than 2 standard errors away from that true P. All right. So, in other words, if we were to randomly pick a P hat and reach out 2 standard errors, 95% of the time, it will be within 2 standard errors of this P. All right, so that's talking about the 95% confidence interval. That is what we're going to be doing. We're going to be randomly picking a P hat. There's a 95% chance it'll be one of these pink ones. And if it is, that means if I were to reach out 2 standard errors, P will be in that interval. All right, so that is the idea. And notice, guys, we are focused on the 95%. Later on, we're going to use, 90% confidence intervals, 99, 98%. You can do any percent you want, but we're going to focus on just 95 today, just to kind of keep it simpler. All right, but later on, we'll branch out from that. But for now, we'll focus on the 95%. Okay. All right. So, any questions so far? All right, so now let's actually do a confidence interval. So I'm just gonna first show you guys just the calculation part, all right? Just so you guys know, the confidence interval process, it's quite a few steps, and calculation is just one part. So by the way, I graded the quizzes. If you didn't do very well on that quiz, it's probably because you either didn't check conditions or you didn't check conditions well. Okay? Checking conditions is half the points. So if you didn't check conditions at all, that was half of the quiz. Okay? And you missed half of it. So don't do that again with confidence intervals. You still have to check conditions just like before. Okay? All right, so I'm going to focus just on the calculations, and then I'll show you one later where it's all the steps with the conditions. Okay, let me see. Alan, can you read this one out for us real quick while I switch over to my iPad? Okay, sorry. Can you read that one more time?
In a sample of 50 students, 35 said they were registered to vote.
Thank you. All right, so 35 out of 50 were registered to vote. So this is 0.7. We're registered to vote. All right, so I'm going to go ahead and show you guys how to do a 95% confidence intervals, just the calculations. All right, so the first thing I'm going to do is I'm going to find the standard error. Okay, so p hat we have is 0.7. The standard error of the p hats will be the square root of p hat q hat over n. All right, so plugging that in, I get the square root of 0.7 times 0.3 all over sample size of 50. Calculator, plugging that all in, I get 0.065. Okay. All right. Thank you. Oh, okay. I'm going to round that to 0.065. Thank you, though. All right. So to find the confidence interval, I'm going to do p hat, and I'm going to add 2 standard errors, and then I'm going to subtract 2 standard errors from that p hat. I'm going to reach out 2 standard errors on both sides. So that gets me 0.7 plus 2 times 0.065, 0.7 minus 2 times 0.065, and that gets me 0.83 and 0.57. All right, so, well, what does all this mean? Okay, so this tells me that I am 95% confident that the interval between, or interval from 0.57 to 0.83 captures the true population proportion of, let me look at the problem, of students registered to vote. Of students registered to vote. All right. Guys, that's your very first confidence interval. So, yay, there it is. Now, think about just the significance of this. It's pretty staggering because basically you have these students, like college students, right? There are thousands and thousands of college students. You took just 50 of them, analyzed it, and found that now you are 95%. That's pretty high. You're 95% confident that your entire population of thousands and thousands of college students, you are 95% confident that between 0.57 to 0.83 of them are registered to vote. That's a huge statement. Collecting 50 people, analyzing it, and now talking about thousands and thousands and thousands of students. I mean, this is actually what they do when they're actually, projecting who's going to win, like the presidential election, right? They're not taking a census of the entire United States. They're taking a sample, and then they analyze it just like we did, and then they're able to make that statement. So this is huge, right? This is huge. Obviously, there's more to this. We haven't checked conditions or anything like that. So we actually can't quite make this statement with 100% confidence yet. But if those conditions were met, then yes, we would be able to make this statement that 95% confident that the majority of students are registered to vote. In fact, it seems like likely the vast majority. All right. Any questions on the calculations? Okay, so kind of going into just a little bit of the nitty gritties. So confidence intervals, like the one we just made. A confidence interval, I don't know why I have parentheses CI, I never use that. But a confidence interval for a population parameter, like the proportion, that population proportion of registered voters that we were trying to find. A confidence interval for a population parameter is an interval of plausible values for that parameter, right? So the interval that we just found, 0.57 to 0.83, that's a whole interval of plausible values for the population proportion, okay? And our primary goal of a confidence interval is to catch that unknown population parameter. We don't know what the true percentage is, but we are 95% confident that it's somewhere between 0.57 to 0.83. Okay, so that is our goal, to catch that unknown population parameter. All right, so notice there's always a degree of confidence. All right, like in this case, we're 95% confident. All right, 95% confident. So all confidence intervals will have that degree of confidence. Okay, formula. The AP Stats Guy video went over, so I won't go into too much detail here. But point estimate, that's your p hat. Your Z star, that's called a critical value, and that is directly linked to how confident you are, right? In our case, we're doing 95% confidence. So the Z star we're actually going to be using a more specific number, which I'll go into a little bit later. But just know that that critical value is directly linked to that percent level of confidence. This is that standard error we talked about. And one more thing is that this whole part behind the plus or minus, this is called the margin of error. The margin of error. Okay. So this determines how wide your confidence interval is, how wide it is. Okay. So let's go into an example, and I'm going to have you read this for us while I switch over to my iPad. So Malika, can you read? I'm going to stop sharing, but can you read it from your notes, and then I'll switch over to my iPad.
Yeah.
All right. So thank you, Malika, for reading that example. Sorry, let me still have my notes out here too. Okay, so we are trying to find a 95% confidence interval for what percent of the population believes that college is essential for success. All right, so a few things I'm going to write down from what Malika said. I know that the sample size is 1,031. And I know that of those people in that sample, 567 out of the 1,031 said that they believed it was essential for success. All right, so that gets me a proportion of 0.55. All right, and we want to create a 95% confidence interval. Now, if it's 95% confidence, we're going to use a Z star of 1.96. Okay. Since this lesson, we're only doing 95% confidence intervals, we're always going to be using that 1.96 for this lesson. All right. For just this lesson. I think starting tomorrow, we're going to change that, and I'll show you guys how to get that Z star. All right. So with that info, here is how to do confidence intervals, the whole shebang. All right. Here we go. Step 1, conditions. All right, so the good news is it's the exact same conditions as chapter 8. So those of you guys who did well on the quiz and you got those conditions down, you have the same conditions down for this. All right, so keep them. First thing is random sample. It doesn't say in the problem that's a random sample, so we're going to assume. Okay, so assume random sample. Oh, by the way, on the quiz, I noticed some people just put random. That's not enough. Random what? You got to be specific. So random sample needs to be there. All right. Second condition, N, P, and Q for proportion. So here I got 1,031 times 0.55. Here I got 1,031 times 0.45. This gets me 567, which is greater than or equal to 10. And this one gets me 464, which is also greater than 10. All right, so same exact conditions. All right, now going on to the newer stuff. Second step is you need to make your statement. Now, the statement you're going to make will have two things. One is what model are you going to use, and what is the process we're going to do. All right. So what are you going to use? What are we going to do? So I will use in this case, we're going to use the normal model. All right, we're going to use the normal model to do A. This is the process. 1 proportion Z interval. A 1 proportion Z interval. Okay, so let me break that down. The reason why it's 1 proportion is because we have 1 sample. So 1 sample is that first one. Proportion, because we're talking about proportions. Z, because normal model, we use, that's all Z scores with normal model, so Z. And interval, because we're making a confidence interval. So 1 proportion Z interval, all right, is what we will do. All right, step 3 is our calculations. So calculations. And this is where we use that formula, right? So p hat plus or minus square root p hat q hat over n. And now let's just plug in our numbers. So we got 0.55 plus or minus square root. Oh, sorry, I forgot the z star. Squeeze that in there. 1.96 times 0.55 times 0.45 all over 1,031. All right, and in the interest of time, I already did this. So the bottom number, if you were to subtract, we would get 0.521. And then the top number, if we were to add, we get 0.579. All right, and that is our interval. So this leads us to our last step, guys, which is to state our conclusion. All right, so our conclusion is always start with how confident you are. Okay, not as a person, but in the interval. Okay, so start with I am 95% confident. Okay, so I'm 95% confident that the interval and it's going from 0.521 to 0.579. Okay. I'm 95% confident that this interval captures the true population proportion of, and now I just look at the problem and see, well, what were we trying to get? And it says we are trying to get that confidence interval for the population proportion of adult Americans who believe that college education is essential for success. All right, so I'm going to kind of basically put that here. The true population proportion of Americans who believe college is essential for success. Whew. All right, guys, that is an entire confidence interval from start to finish. 4 steps: condition, statement, calculations, conclusions. And again, notice calculations is just one small part of it. There's everything else, is just as important to make sure you get this confidence interval right. Okay, let me take a pause because I know that was a lot of info. Kind of digest it, marinate in it just a bit, and let me know if there's any questions.
Right now.
Perfect. All right, so go ahead and read that once you have it. It starts with your local newspaper.
Okay. Your local newspaper polls a random sample of 330 voters, finding 144 who say they will vote yes on the upcoming school budget. Create a 95% confidence interval for the actual sentiment of all voters. Use Z star equals 1.96.
Perfect. All right. So that is what I got from what Megan said. So we are doing a 95% confidence interval, sample size of 330. Of those, 144 said they would vote yes on the school budget. Okay. And we want to create that 95% confidence interval. All right. So let me start calling on people and let's see what you guys can do from that other example. All right. So let me start with Tiffany. Tiffany, what is step 1?
I found that the p hat is 0.44.
Oh, okay. Oh, that's useful. Okay. So we got 0.44.
Yeah, and then start off with conditions.
Good. Conditions. Okay. So just help me with that first condition.
It says in the question that the poll is a random sample.
Good. So what should I write down?
It's a random sample.
Good. Yes. You'd be surprised. Some people just say, just write random, and they're like, that's it. No, that's actually not it. So you want to specify it's a random sample. Thank you, Tiffany. So yeah, even if you just write random sample, I'm okay with that. But just make sure you tell me what you're checking as random. Okay. All right, nice. Let's go Megan G. Help me with the second condition.
So you do P times Q, and that's 145.2.
Sorry, wait. P times Q or
Well, you have to, oh, I meant N times P, sorry.
okay, there you go. I was like, I think you got the right number, but yeah, okay.
Yeah, okay. And then for NQ, it's 184.8.
Awesome. All right, so that sorry, let me write down the work in case people aren't sure where those numbers are coming from. So Megan, what was the first number you said?
145.2.
Okay, perfect. And
And
then
then 184.8.
84.8. Okay, awesome. And those have to be greater than or equal to what?
10.
10. Perfect. Nicely done. Okay, conditions. Done. Nice. Let's go to our second step, which is what? Let's go, Scott. What is our next step?
We have to make a statement
Nice. What is our statement?
as it I will use a normal model
Yep.
to do a one proportion z interval.
Perfect. Nicely done. All right. So I will use a normal model to do and I'll even shortcut this for you guys. You can write one prop z int. All right. So you can abbreviate that. I'm totally okay with that. Okay. So one proportion z interval, one prop z int. Nice. Okay, let's go to step 3. We got to do some calculations. Okay, so the formula, I'll go ahead and write down. This is p hat plus or minus z star square root of pq hats over n. Okay, help me start plugging things in. Evan, what's p hat?
P hat.
Mm-hmm.
P hat should be 0.44.
Good. What's z star?
Z star should be 1.96.
Good. Keep going.
P and then it's P hat, so it's 0.44 times the Q hat, which should be 0.56,
Good. All over.
and which is 330.
Perfect. Nicely done, Evan. All right. And again, interest of time, because I trust you guys know how to use your calculators, but I would practice. There's a lot going on there. But you should get about 0.39 to 0.49 is what I get on my calculator. All right. So far, so good, guys. Nice. Let's go to the last part, which is our conclusion. That says conclusion. Okay. So help me make this last statement, all right, because this kind of puts it all together at the end. Let's go to Andrea. What do you think?
You have to say, I am 95% confident that the interval from 0.39 to 0.49 captures the true population proportion of the actual sentiment of all voters.
Close. Just that last sentence, I think, or the last part, I would change a little bit, but the first part, perfect. I'm just trying to catch up with you. I am 95% confident that the interval from 0.39 to 0.49 captures the true population proportion of. Okay, now here, let's go ahead and look at the problem a little bit. What are we trying to catch the proportion of? Because
Of the voters who say yes.
there you go. Yeah, it's hard to find a proportion of sentiment. You know what I mean? So I think I like what you had there, where people who would vote yes on that budget. Okay. So capture the true population proportion of voters who would vote yes on the upcoming school budget. All right. And there it is. Awesome job, guys. Nice. Okay, let me see if there's any questions now that you guys you see two examples of it now.